The upper and lower bounds theorem states this. Assume f of x is a polynomial with real coefficients, a positive leading coefficient, and degree greater than or equal to 1. Let a and b be fixed numbers with a less than or equal to 0, not less than or equal to, a less than 0 less than b. Then, no real 0 of f is larger than b, so b is an upper bound, if the last row in the synthetic division of f of x by x minus b contains no negative numbers. That is, b is an upper bound of the zeros if the quotient and remainder have no negative coefficients when the function is divided by x minus b. No real 0 of f is smaller than a, so a is a lower bound if the last row in the synthetic division of f of x by x minus a has entries that alternate in sign. 0 can be counted as either positive or negative as necessary. So let's just pick a number at random. Let's pick the number 2. So let's try 2 in synthetic division. We'll bring down the 9 and multiply, and add, and multiply, and add, and multiply, and add. That's supposed to be a 15, not a 45. So we're looking for either alternating signs, or we're looking for no negative signs. This has neither of those things. So let's try 3. Multiply, add, multiply, add, multiply, add. Notice how all of these are positive? That means 3 is an upper bound. It does not mean that 3 is as high as it possibly goes or even as low as it possibly goes on the upper end. It just means there aren't any zeros for this polynomial greater than 3. So 3 is an upper bound. So how do we go about finding a lower bound? Let's try a negative, a negative 3. Let's see if that works. That would be negative 27, negative 30. This would be a positive 90. Negative 45 plus 9 is a positive 45. 3 times 45. This will give us a negative 135. When we add those, we get a negative 120. Look at there. If you notice, we have alternating signs. If they alternate in sign, then this will be a lower bound for your zeros. So negative 3 is a lower bound. So this narrows down your search even further. If you have that long list of possible rational zeros, then this will kind of limit what you should look at. Let's go back for just a moment to slide number 5. Do you see how we have this long list? This was actually the same problem. We know that 3 is an upper bound, and we know that the negative 3 is a lower bound. So we shouldn't look at anything less than negative 3, and we shouldn't look at anything more than 3. Do you notice how our zeros actually do fall into that category? So that's what this whole upper and lower bounds means. Pause the video, read the caution. This is a very, very important thing for you to know. Assume that f of x is a polynomial with real coefficients and that a and b are real numbers such that a is less than b. If f of a and f of b differ in sign, then there is at least one point c such that c is between a and b and f of c equals 0. That is, at least one 0 of f lies between a and b. Here's what that means. Let's say this is your function. And we know that if we plug in a 4 and we get a positive, and we put in a 5 and we get a negative, that means that there's a 0 between 4 and 5. So, show that this function has a 0 between 1 and 2. Well, what is f of 1? Calculate it. We can either just plug it in or we can do synthetic division. F of 1, I don't know if I can squeeze that in, but we can try. 4, negative 5, negative 36, and 45. So 4, 4, negative 1, negative 1, negative 37, negative 37. So 45 minus 37 is 8. So this came out to be positive. F of 1 is 8. Well, what is f of 2? Four, 8, 3, 6, negative 30, negative 90, negative 45. So f of 2 is negative 45. This means since this one is positive and this one is negative, this means that there is a 0 between 1 and 2. So how do we find an approximation of that 0 to the nearest tenth? Well, let's just pick whatever's right in the middle of 1 and 2. That would be 1.5, right? So try 1.5. I think instead of doing synthetic division for this one, we might as well just go ahead and plug that one straight into the function. So f of 1.5 is equal to what? It's actually equal to negative 6.75. This came out to be negative, so that means it's not between 1.5 and 2 because both of those are negative. That means it must be between 1 because that came out to be positive and 1.5 because that came out to be negative. So let's try something right between 1 and 1.5. How about 1.25? What does that come out to be? It comes out to be 0. So what you just did was approximate it, but then it turns out to be you found exactly the 0. So an approximation to the nearest tenth, this would be tenths place. So if you did round it, it would be x equals 1.3. Although 1.25 is the actual 0.